I come in as somebody that's leaning a little bit on the theory side. And my task today is to talk about the importance of model, especially if you are not going to be a theory person on the empirical side. And so I'm one person that does theory work on this panel, and I'm very humbled by the people that came in before me to talk. And I think we're all sort of a little bit leaning towards the theory side. But I want to talk more generally, especially if you're not leaning towards the theory, why models are still very important. So before I launch into this, I just want to give you a little bit of background. And I came to the University of Colorado Boulder just a few minutes from here, 23 years ago. And it was a dual body problem. So I'm happy to talk about that if you have that similar situation. It was difficult, but it's really great to have friends in the profession. If it doesn't work out on the first try, it's really great to have friends in the profession so that you relocate at some point. I also chose to have children during my tenure clock, my two children. By the way, also my husband's tenure clock was coinciding with mine. So we chose to have children when the time was really crazy, but it all worked out. So I'm happy to talk about that too. On the research side, I'm a modeler in corporate finance. So I do structural estimations. On the teaching side, I actually love teaching. It gives you instant feedback and it kind of feeds you, whereas research sometimes is nonlinear and you like to have that feedback earlier. So teaching can be energizing. On the service side, I'm the type of person that if I see a newspaper lying on the floor, I am going to pick it up, so you know I care too much. I've ended up directing our PG program and I'm now chairing my division. So that's the part about me if you want to talk more generally about these topics. But today, I'm going to talk about the importance of models. And so this is our profession. There's been a decline of publications for theory work, and it doesn't extend to today, but you can see that the RFS was started with a keen interest on modelers, and it has decreased over time. And that's okay. I mean, we have such a wealth of data that to do estimations in finance is quite natural. And you can do reduced form estimation, or you can do more structural estimation. So there's always a place for model, which is going to be the central point that I want to talk about today. So to give you an example, you start with a fact, the Phillips Curve. So the inflation rate being inversely related to the unemployment rate. And this was a statistical fact, well known, and we would talk about this. But over time, that statistical fact has changed to now the Phillips curve is no longer a fact, because we know that there's something else driving it. So the aggregate demand both determines the inflation and the employment. Okay, so there was a third force here that actually was driving both both dimensions here. So if you can see here in yellow, our Phillips curve right now is kind of flat. So if you're interested in doing empirical work and you uncover in correlation, and of course, it can be something very famous, you still need a model to think about those two variables and whether they actually might be caused by a third one, because then it will not survive for as long as you think it should. So then, of course, in '95, we had the Lucas critique that told us that agents are optimizing given the structure of the economy. When the structure changes, those decisions, those optimal decisions will likely change. So you cannot have government policy being determined based on a correlation, because that correlation, just like we've seen for the Phillips curves, will change. So, for example, Fort Knox, that has half of the gold in the US, a very heavily guarded place. Should we continue spending money on guarding Fort Knox? Well, if you look at the correlation, it's never been robbed. So spending money there probably is the waste if you think that the tendency of the past will continue. So the policy recommendation, just based on correlation, could say, stop spending money. But of course, that's not the correct one. Similarly, there's been studies in the early 1990s that shown that at the introduction of the seatbelts, there's been more car accidents. So seatbelts are dangerous? Of course they're not. But with the seatbelt, people started driving a little bit more carelessly. And yes, there was an actual increase in car accidents, a decrease in fatalities. All right, so people optimize. If you change the security level, if you change the requirement to wear a seatbelt, people's behavior will be different. And this is why models are so important. Even if all you want to do is empirical work, if your specialty and interest relies on empirical work, you still need a model. So everyone uses models. We all do. To do research is try to understand the world. You have to have a model in your head of what is going on in the world. That's how you come up with your hypothesis. And you have to kind of figure out in the world that you're thinking about, what is an X variable and what is a Y variable, right? What are the X variables that actually were predetermined last year that you can put as explanatory variables? Which are the ones that are totally outside of your thinking that nevertheless you should control for, so those exogenous variables. And then the variable of interest, your Y. So to some levels, we're already, all of us, doing that, just categorizing what we want to look at between X and Y variables, and that involves a mental construct, therefore a model. So a model precedes estimation for sure. And I'm going to talk about different levels of models, like the descriptive statistics that we just talked about. When you want to measure something, you have to think about what is the best way to measure it. And that requires you to think and kind of model exactly what you're trying to measure. And then there's going to be those verbal theories that you have something that is so intuitive that you can just state as the hypothesis. And so I'm going to call it for today the verbal theory. The next step is maybe a reduced form of somebody else's model, or maybe your model, but now you're not going to estimate the model itself. You're just going to do that reduced form estimation. Next step up is you want to look at multiple predictions of that model. So you may have comparative statics, so a broad range of empirical predictions that you want to be testing. And finally, what I have here is maybe you're interested in things that are not very observable. Maybe what you want is to determine if the risk aversion of people have changed over time. And that's not something that we observe. So how can you dig that out from the data? You put some structure in a model and you estimate it. Same goes for bargaining power, if that has changed over time, for example, or the technology parameter of, for example, a Cobb-Douglas production function. So different levels, all including some theory. And I'm going to inspire myself here from a paper that my good friend Vincent Glod and co-author published, is that this is the progression of how useful a model is going to be for you. So you can start from that descriptive all the way to the structural. And on that line here, everybody's doing an estimation. Everybody's doing some form of a model, and it progresses to the right-hand side as you get more and more into using the model for the estimation. All right, so let's talk about descriptive statistics. So that's the first thing here that I had talked about on that line. And you found a correlation in the data. That's great. It's great unless you ran 10,000 regressions to find that one correlation, right? So we now know that we need to adjust our p statistics for the model selection. Okay, so adjust your t statistics and see if you still have a result. And then think about, is it spurious? One way to answer that is have a model and try to think about whether that correlation should be there, what kind of mechanism is driving that correlation, and now you have a paper. The model is going to help you understand the why, right, the mechanism, but what I want to talk about is also the how much. So it's very nice to know that an effect can increase or decrease something, but to say what the magnitude of the increase should be is actually even more interesting, right? So that quantification of the effect is something that nowadays people more and more are interested in. All right, so first notch was the descriptive statistics. Now let's go up a notch and talk about the verbal theory. So there are things that are so intuitive that you think, of course, there's no use writing down a model. I could say, like, are high dividend firms more valuable? Everybody loves dividends. It seems natural that the high dividend firms should be more valuable. And you may be thinking, yeah, maybe Nathalie's okay on this one, or maybe not, right? So if you think about the Modigliani-Miller theorem, dividends shouldn't matter at all. If you think that a firm is high dividend paying, that's maybe because it has reached that mature stage where it's not growing very much anymore. Okay, so there's all sorts of contexts here where high dividend firms should not be more valuable. So that's exactly why, even though it seems intuitive, you may want to write down a model and just verify, is your intuition correct here? How do you generate other hypotheses from this intuition or these assumptions that you're operating under? So it's very important as you think about one issue that you're trying to prove to have supporting evidence all along that same line of questioning. So having a model or framework allows you to derive not just one prediction, but a host of prediction, which makes your work more robust. And if you're going to do the verbal theory approach, what's going to be very difficult for you is to come up with counterintuitive results, right? Because you're starting from an intuitive standpoint. So how do you find the things that are surprising? So that is probably a big limitation of that approach. All right, so I'm going to skip over a few steps and talk about the structural estimation. So that magnitude rather than directional effect. A calibrated or estimated model provides you that ability to pin down what should be the number that you find in the data. So that actually is very interesting. And then you can shut down the mechanism. And if you shut down the mechanism, you can also figure out what should be the number in the data. So you have your counterfactual here, And both of them could be different from 0, right? So the quantification exercise could be very useful. You can find out whether the number ends up being too low or too high compared to what your model would predict. And I want to say here that regardless whether you do difference in difference estimations or you do a structural estimation, of course, we all want to have a setting that allows us to consider some causality rather than correlation, right? So both settings would do that. And in the model, what's great is you have a clean world where you can examine just one mechanism at a time, right? So you construct your world, and if that mechanism is important, these are the predictions. With a setting that is empirical, there may be multiple mechanisms at work, and so the hurdle for you is a little bit higher because you have to take into account all the mechanisms that could be at work and rule them out. So that's kind of one thing that favors models, because we kind of can construct our own world and figure out if that's how the actual world behaves. All right, so I think that modeling is thinking. So whatever a hypothesis you come up with, you have to understand what your assumptions are and what the implications of your work also have along many dimensions. So I want to take the example of the Modigliani-Miller theorem, which we know doesn't hold in the data, right? There's many frictions, we have taxes, default costs, we have information asymmetry, but that is such an important model because it allows us to examine which friction is important in the real world, and using that friction that we add to the mix, then it's going to have one clear interpretation. So it's going to predict, with taxes being important, that you might have more debt, or default costs more important, that you have less debt, and so on. So the model gets you to ask the right questions, and just going from your assumptions being clearly defined, what is the one assumption that in the data might be violated? That's going to be helpful for you to draw out your predictions. And it also gives you very interesting insights into, like, people are behaving in this crazy way that the model would not be predicting. For example, the WACC fallacy, if you have debt that you can finance at 6% and equities requiring 12%, you on the board of directors should always recommend that the CFO takes on more and more debt. And that's what people do in reality. Okay, so we have to think about why that doesn't make sense. That doesn't make sense because you end up having more risk into the firm up to a point where it's not optimal anymore. And similar thing for the earnings per share fallacy. You have analysts that are very focused on that, but that's, again, a risk play. You can always maximize your earnings per share, and basically adding more risk into the firm. More risk, more debt, more risk increases your earnings per share, but that is maximizing earnings per share and not maximizing firm value. So again, it's very interesting to think about the model, the assumptions in a frictionless world, and then think about behaviors that are violating those assumptions. And so you can have a lot of mileage into a question that you're interested in, not only the first hypothesis that you started with. All right, so, in my own life, as I try to do some good research, sometimes I find myself, that line of where you do the project, sometimes, you know, I've come across a descriptive statistic that I thought was new. You know, nobody had seen that before in the data. And so I just start working with the descriptive statistic, and I tack on a model to kind of explain this new stylized fact that I thought was new. And sometimes I start from the end of the line where I do a structural estimation. So this literature has been going for a long time, and it's just slowly progressing towards that end of the line in terms of the modeling. And I add a model and I estimate it, and I can speak about the deeper parameters, the risk aversion, for example, or the bargaining power. And so there's many ways of going at it, of contributing. And so not one is better than the other, but it just depends on what kind of research question you stumble on. Complexity is not always a good thing. So do not always go for the structural estimation because it's hard, right? So you don't want to do that. You want to answer interesting questions, and simplicity actually will get you more airtime with the people that you're talking to, because they're going to get it. It's like, yeah, okay, that's actually a first order finding. I'm going to remember. And so as you are going in the profession, at some point you're going to be asking for tenure, and you want to be known for an idea. And the more simple, easily to convey idea is going to work in your favor. However, as a PhD student, you want to display that you're okay with complexity. You can handle, you know, complicated things and do them very proficiently. So there is a trade-off, but don't always go for complexity. Definitely is not the goal here. So you may want to use complexity to signal, but in the end, you want to build a portfolio that has traction with others. So simplicity is always a good thing. So in thinking about your next research question, as I said, you can start from the beginning of the line. You have a new stylized fact that nobody seemed to have noticed. You can build a toy model, or, you know, a simple explanation with some simple mathematics to show that this is why. This is fantastic. So you're starting with a little bit more at the beginning of the arrow here. Or if there's a literature that's been going on for a long time and there's a debate and the debate is raging and nobody seems to agree on how to look at it, and you can impose some structure and estimate and find the solution to that debate, this is great. So there's many ways of going about how to think about your estimation, and whether you need a small model or a big one. Okay, but always know that when you do your estimation, you will need some kind of model, and you can play on your creativity. If you are a very creative type, you may find yourself at the beginning of this line just creating new literatures, noticing work that stylized fact that people haven't noticed before, and that is fantastic. You might get less citations at the beginning because it will take time for people to start grabbing on to these new stylized facts. If you are a person that is able to impose some structure and resolve puzzles that have been going on for a long time, well, that is great, because you are super high skill. Like, you know, if you can provide something to a literature that has been going on for 10, 15 years, that is special. Okay, so that's going to require some kind of special skill at that. So obviously doing research is hard, and there's, you know, on the creativity or the skill part, depending on where the question that you're thinking about ends up landing you. I want to close a little bit with a quote here that says that experience without theory is blind, because we would basically look at a statement that seems intuitive but may not make much sense. On the other hand, theory without experience is just play, right? It might be fun, but it's better to be useful. So I would say use the theory. And I think I'm going to stop there.